Joining us today on Superheroes of Science, we are so pleased to welcome Dr. David Padgett. Dr. Padgett is an associate professor of geography at Tennessee State University. So welcome and thank you for taking the time to join us this afternoon.
Well, good afternoon. So I'm going to start by sharing my screen. I do have a PowerPoint presentation. So today I'm going to be talking about sea level rise in North American coastal regions and impacts upon coastal aquatic ecosystems. And so again, on the screen that's me on the left, of course, and then the image there is of the Great Fox Island, which is in Chesapeake Bay. I grew up in Baltimore, Maryland. I spent a lot of time in Chesapeake Bay, on the bay. And so that picture is going to take significance in a couple of minutes or seconds. You don't have to read all this. It's just a little bit of my background. And so I've, among other things, I'm also a global observations and benefit the environment partner and trainer for Tennessee State University. And so GLOBE is a program funded mostly by NASA that has as its primary goal improving science education at the kindergarten through 12th grade level. I've also been a GIS consultant, and I've won a few awards, and I'm a native of Baltimore, Maryland, and I'm a proud graduate of the Western Kentucky University Hilltoppers and the University of Florida Gators. But before all of that happened, I was growing up in Baltimore, Maryland, and 40 years ago, I was in the Chesapeake Bay Foundation Summer Science Research Program. I guess I must have been 16 because I'm 56 now. And the project took place on the at the Fox Island Education Center, and we spent the summer engaged in all times of estuarine ecosystems research. And so on the, I guess, right side of the screen, or the other side of the screen, is a map that I drew 40 years ago. And during this pandemic, I hadn't seen my parents in about a year and a half. And when I went home, my mother started digging through some of our old stuff and found this old map that I drew 40 years ago of Fox Island. And you might notice my north arrow, isn't exactly where it should be, of course. And of course, you'll notice that maybe over 40 years' time, the island has changed. It doesn't seem as if it's as large as it was, assuming that my cartography was on point. If you notice the point symbols on the map, my project that summer was to determine the relationship between the vegetation or estuarine vegetation and insect habitats. And so I was trying to determine if there was a spatial correlation between where different insects were found on the island and different plants, or did certain insects favor different plant species. So that was my project for the summer. And not to toot my own horn, but I won best project that summer. So that was when I was 16. Had no idea that I was going to become a geographer. No idea that I'd be drawing maps and spending time in studying coastal areas past that point. So I'm going to talk about sea level rise and just how some of the ways that I've been going about studying it related to some of the work that I'm currently doing in and around coastal Alabama. And interestingly enough, some of you might have heard on the news that the International Panel on Climate Change, the IPCC, released its 6th assessment report, like literally just released it just in time for this presentation. So part of that report discusses the relationship between climate change and sea level rise. So we'll take a quick look at that. And then we'll delve into the impacts of sea level rise upon coastal aquatic ecosystems just a little bit, just to give you a brief introduction. We can't we don't have nearly enough time to really get deep into it, but just enough to give you a taste. And then we'll talk about a specific coastal ecosystem, wetlands ecosystems that are being significantly negatively impacted by sea level rise. So just a little background. What I'm doing in the area around Mobile Bay is developing the backdrop, I guess you could call it, or the planning phase for what will eventually become the Africatown Connections Blueway project. So when you've probably heard of a greenway where you ride bikes and go jogging, but this is a blueway where people can go kayaking and fishing and canoeing and whatever else people do in this coastal region. And at the same time, learn about the history of a place called Africatown, which I don't have nearly enough time to talk about. But if you Google Africatown, Mobile, Alabama, you will learn about this fascinating story. As a matter of fact, it was the cover story on National Geographic magazine in February of 2020. And it basically tells the story of the last known ship that transported Africans who came here to be enslaved. And that happened in 1860. And archaeologists found the ship in 2018. And so that has brought a lot of attention to this community. And they are working on developing what they call heritage tourism. If you also Google a place called Williamsburg, Virginia, or Colonial Williamsburg, that's similar to what the people of Mobile want to have happen with Africatown, taking this rich history and making it a place where people can come and visit and learn. And in this case, boat and kayak and fish and spend time around the water. And so this is a project that's done in collaboration with the National Park Service. Part of my background is in geographic information systems. And so the National Park Service Cultural Division did not have and does not have geographic information systems technology capacity. And so they came to me. I had already been working in the community prior to this envisioning of this Blueway, and asked me to develop a map. And then afterwards, they came and said, well, we want to do some design, some architectural landscape design on some of these sites. Can you also capture some drone images? And so we went there earlier this summer, we meaning myself and my drone pilot. And so this is Dr. Claire Grove, who also happens to be a medical doctor. And in fact, she is an alum of Indiana University right down the road. And so she also is a Federal Aviation Administration licensed drone or unmanned aerial vehicle pilot. And so in order to do commercial work such as this, you have to have that license. And just as an aside, about 95% of FAA licensed drone pilots are men. And obviously Claire is a woman, she's also a woman of color. And so she is a very important role model in terms of science, technology, engineering, and math. She's such a multifaceted individual. And so she flew our DJI Mavic 2 drone, as you can see it there. And you see the remote control on the other side. You can also
looks like a very impressive looking drone.
Yeah, it's
wow.
Yeah, $6,000 worth of impressive, which is why I wasn't flying it. I need to get somebody here who's not going to crash, lose, especially flying over water. So yeah, I just met Claire by chance while I was on vacation, and we started talking. And she's now an empty nester, and she's doing her thing now. You know, the kids are out of the house, and she's doing drones now, and still doing medical consulting. But anyway, so
fun.
So a lot of us, you know, we think of sea level rise. a lot of us unfortunately get our first exposure to this kind of concept through Hollywood. And I can't think of any movies, but I've seen a couple. There was one called, I can't think of it. It was called Geostorm or something like that.
Oh, yes. One of my
And
favorite B movies.
yeah, that one is like, come on. And now they've got one. I haven't seen it. I fell asleep on it. It's called, it's a Lifetime movie. It's called Psycho Storm Chaser. Now the first 5 minutes, if you know anything about weather and climate, what have you, falling out of your chair laughing. I mean, but it's not as bad as Twister. The Twister was really bad. Entertainment value, but I've been in tornadoes, like in them, just like that, and you're not cracking any jokes, watching any debris fly by. Whoever you pray to, you find them right then and there. That tornado bears down on you. There's none of that joking around and talking about your relationship and are we gonna be together? No. Anyway, but really, sea level rise is not as violent as that. It's very subtle. And if you look at these pictures so I have some. Now this is a restaurant called the Off the Hook Marina and Grill. And if you notice this area, I think this is not a hotel, but like a place where people can kind of, I don't know what it is, but it's a place where people have living quarters.
Okay.
And the restaurant is here, and you can see the ground view, and there hadn't been any rain in this area for days. And yet you can see that it might not be too long before people have a problem dining at the Off the Hook Marina and Grill, of course, unless you want to do boat-in dining. This is an outdoor dining deck here. They're supposed to be able to walk to it. And so we saw this for everywhere we went in this coastal area, no rain. And yet
these aren't like flood conditions either.
Oh, there was no rain. This is just sea level coming up, encroaching. And in one place that I'll show you perhaps next, this is the Williamsbrook Park in Mobile. And this is a park. Here's a park pavilion. You're supposed to be able to walk across here and not swim across. And so this is very subtle, and it's disruptive. I mean, we saw places where there were restaurants that had parking lots that had 2 and 3 feet of water throughout the entire parking lot. So you can just see the impacts of this. And when I was in the coastal region in Louisiana years ago, I was taken to what used to be clamming and fishing communities that aren't there anymore. And really, even before the communities were flooded and they lost their land, they left because the changing chemistry of the water wiped out the oyster beds. And that's how these people made a living. And so once the oyster beds were gone due to sea level rise, there went their livelihood, and they had to go. And so it doesn't seem as if it's a lot of rides. It's just a little water in the parking lot, but that change in water chemistry can result in huge impacts to these aquatic ecosystems. And I just thought that, if you're not living in a coastal area, you might not notice this, but we can
just because
the
the level is rising, how is that changing the chemistry itself?
Well, if you have water that is, estuarine or saline or has salt water and it mixes in with too much fresh water, aquatic life has very narrow tolerance ranges for things like pH. So let's say there's a fish that has a pH tolerance between 6.5 and 6.8, let's say. And something happens that changes the water chemistry, that pH level drops to 6.4. All of those fish die, not some of them, all of them. And so, and you might say, well, wow, isn't that fickle? But think about human beings. Our body temperature is 98.6 degrees Fahrenheit on average. And if it goes up only 3 degrees Fahrenheit to 101 degrees Fahrenheit, you're in deep trouble. If it goes up a few more degrees to only 103 degrees Fahrenheit, you're in serious trouble. And so it's only a couple of degrees. So fish are the same way, or aquatic life is the same way with pH. If it changes, or if the amount of salinity in water changes, it can wipe out plant life. And that's exactly what is happening throughout this region. So going back into that Intergovernmental Panel on Climate Change report, here are a couple of graphs that just show that we go back, many years, 2,000 years or so. We can see that the surface temperature stayed pretty steady, and then since the Industrial Revolution, that's what that 1850 represents. And the Industrial Revolution can be defined in many ways. In terms of, I guess, geology or ecology or geoscience, it's usually defined as when we, human beings, went from primarily using renewable resources for energy, water, wind, etc., wood, to using non-renewable resources for energy, coal, gasoline, and so on, and so electricity, and so on and so forth. And so you can see that the greenhouse gases, carbon dioxide being the main one, resulted in warming. And the way that this works, this meaning the introduction of carbon dioxide into the atmosphere, is that when sun rays come in from the sun, they come in as what you might call ultraviolet radiation. If you ever use sunscreen, there's a number that corresponds to ultraviolet radiation. That's that shortwave radiation that comes in from the sun. That doesn't warm the atmosphere. What happens is that radiation is absorbed by the Earth and then released into the atmosphere as long wave or terrestrial radiation, which is absorbed by carbon dioxide, also absorbed by water vapor, also absorbed by methane and other greenhouse gases. And when we as human beings burn fossil fuels, we pump a lot more carbon dioxide in the atmosphere than nature ever intended. And of course, it results in warming. And if I had time, I would show you that the atmosphere, Earth's atmosphere, or the lower atmosphere where we are, is about 80% nitrogen, maybe about 19% oxygen. A lot of people think that the atmosphere is oxygen rich. And so that last 1%, all the other gases, including carbon dioxide, comprise that last less than 1% of the atmosphere. And so it might cause you to ask, well, how can that little tiny volume of carbon dioxide cause all this trouble and disruption? How can that be? But scientists, or atmospheric scientists, have built models, very complex models on supercomputers, to model the atmosphere. And when they have tweaked carbon dioxide, they see the subsequent change in temperature. So yes, that little bit of carbon dioxide does make that much of a difference. And we've heard all of the arguments for and against climate change. And the argument is not if climate change is or is not happening. That's not the argument. The argument is it human caused? Is it anthropocentric? Or is it natural? And certainly the Earth's atmosphere does change on its own. We've had a couple of ice ages and there were no humans in sight. No cars, nothing. The atmosphere got colder, then it warmed up. We didn't have anything to do with that. And there are some people who are arguing, well, the Earth's just warming up on its own. We humans are too insignificant to have this great of an effect upon the atmosphere. How can we think that we're so great that we can cause all this damage when one volcano, a single volcano by itself, a single volcanic eruption, can put enough material in the atmosphere to alter global temperatures for a few years afterwards. One volcano. So maybe nature is just too big and bad for us to think that we can do that. But so there's an argument, but whether or not we agree on how it's happening, something has to be done, because even doing nothing will have a result, and it might not be a good one. And so here is the relationship between climate change and sea level rise. I really like this graphic. So you have carbon dioxide, highest it's ever been, at least that we know of as humans. Sea level rise is rising. Of course, the glaciers are retreating. Arctic sea ice is going away. And so all these things result in sea level rise. And so this is a graphic which comes from a NASA and NOAA report on what is called sunny day flooding. And so, or in part, sunny day flooding. And that was the topic of, or probably that's what I was showing graphically or in those drone images, is it's sunny and it still floods, no rain. And so when that happens, as you can see, among in addition to it being a nuisance to us, this tidal flooding, this especially occurs in coastal areas. Our storm systems are designed for normal conditions. When it rains, we get flooding. But if we get flooding when it's not raining, guess what happens when rain is added to that? Then we have a situation that we haven't planned for, where there's far more flooding than we ever anticipated. And just while I'm on the topic, some of you might have heard in the news about that terrible tragedy in South Florida, where that condo building collapsed. And there was a discussion in part that said that it was in part due to the fact that when the sea level rises, it pushes, it's called saltwater intrusion. And so that salt water intrudes underground into the foundations of buildings. And so the engineers observed that the building wasn't that old. It was only 40 years old. But when you have salt water instead of fresh water coming into contact with rebar steel that's inside of concrete and just dissolves it away, then you see, that was seen as being a contributing factor, in addition to some design flaws. The core, apparently the engineers know that this happens in coastal areas, so they supposedly designed the foundations of these structures to be sloped so that the water will run off. But this saline water was ponding because that slope wasn't great enough, and it dissolved the base of the building. And unfortunately, humans make mistakes, and there were mistakes made that really cost almost 100 people their lives in that terrible tragedy. But it was in part due to this interaction between salt water and fresh water. But in terms of impacts to ecosystems, as you can see here in red, when this water flows off of the mainland into coastal waters, it causes a series of chemical reactions that increase the rate of decay and increase algal bloom, which sucks oxygen out of the water. And I'm trying to use as simple an explanation as I can for what happens. But basically, when you get an overgrowth of algae due to these nutrients flowing in as a result of this increased interaction between salt and fresh water, eventually the algae have to die, they fall to the bottom, and that process really downgrades the oxygen that is available in water for fish and other aquatic life. And so it's been observed that there are entire portions of coastal areas that are now dead zones, where nothing can survive, not fish, not shellfish, not anything. And so this is a very serious effect of sea level rise, which is associated with global warming in terms of ecosystem destruction.
Dr. Padgett,
Yes.
last figure that you were showing, could you say a little more about how it gets to the point where the spawning algae blooms? So you said water. What's the process again? So the water is.
Yeah,
Mhm.
so part of it, there is a human impact. I mean, a lot of, we use fertilizers and all kinds of things on our land. And when that daylight flooding, when that water eventually has to run off, and you eventually get more of that runoff than would normally occur with sea level rise combined with this type of daylight flooding. And that introduces nutrients such as phosphates. And phosphates, that's what's used in fertilizer.
Yeah.
And it just causes plants to grow and overgrow in water, and they just take over and eventually die. And through that biodegradation, that results in consumption of oxygen. And so, as a net result, you have loss of oxygen.
Thank you.
It's almost like putting fertilizer in the water and just throwing things completely out of balance. And so here's the result, and you can see these are probably satellite. These could be drone. This could be drone or satellite images. This is from the EPA, and you can see what happens to aquatic life when these algal blooms occur in coastal areas. And it's a combination between our use of land, introducing fertilizers on our lawns, and especially in agricultural practices, and then that combines with the plant life that already exists. It overgrows, it dies, and it just robs fish and other aquatic life of oxygen. And it's a very difficult issue to control. No need to read all of this, but I'm going to now move on to wetlands. Wetlands are very important ecosystems. They serve many functions. Wetlands are nature's flood control system. They slow down the velocity of floods. So if there is a hurricane or a tropical storm, if wetlands are there, they will slow down the velocity of the storm surge. And it's that storm surge velocity that causes a lot of damage in coastal areas. Also, wetlands from an ecosystem standpoint, about the majority of the fish that we eat are born and bred in wetlands ecosystems, the majority of them. If we get rid of the wetlands, if the wetlands are lost due to sea level rise, then guess what? We lose a substantial portion of the seafood industry. So wetland ecosystems keep shorelines intact, and they serve a variety of functions, but they're very fragile ecosystems that really depend upon balance amongst water, land, and plant life. It's a very specific balance that is really maintained by the flow of water through them. And so if you ever hear of something called wetland function, that's basically a measure of the flow of water through the ecosystem. And if that flow of water changes in any way, if there's less of it or if there's too much of it, it'll alter the entire ecosystem. Certain plant species that like water, if they don't get enough water, they'll die. There's certain plant species that are more upland. If they get too much water, they'll die off. It'll destroy the entire wetland ecosystem. And so, here is how sea level rise has a direct impact upon the loss of coastal wetlands, which is happening at a rapid pace. I'm just throwing this in so perhaps you can do your own research. This is the U.S. Fish and Wildlife Service's Wetlands Mapper, and you can use this tool yourself to look at and examine wetlands and riparian areas throughout the United States. And there's the link. And I invite you to take a look at these ecosystems that are amongst our most precious and most endangered. And you can see how any change in the elevation of the sea can significantly alter these ecosystems. And so this is a neat site, and you might learn a little bit about geographic information systems and mapping using this site. So here is a graphic of a wetland ecosystem, specifically a Gulf coastal wetland ecosystem. And notice that we have 4 parts of a wetland ecosystem. There's open water, and then that's part 1. The second part is the part that's covered by submerged plants. So you have water lilies, cattails, or partially submerged plants. Then you have plants that are not submerged, but they really like to exist in very moist soil. That's the third part. And then the last part of these upland plants. And so a lot of people make the mistake of thinking that, well, these upland plants, they're not really part of the wetland ecosystem. They absolutely are. All of these 4 parts, open water, submerged plants, water-loving plants, and upland plants, all 4 of these parts of the wetland ecosystem are necessary for this ecosystem to function and provide us with all of these various species that depend upon this system's remaining in balance to survive. And so again, what happens is if we get sea level rise and too much salt water gets into these plants that might not like salt a whole lot, they'll die. And so this is why these very delicate ecosystems are in trouble. Then of course, if the plants died, and that's going to affect the wildlife, and then if the fish died, and this blue heron here won't have anything to eat, it's not going to be there anymore, and so on and so forth. And so anything that disrupts the food chain at any part is going to have a significant impact. Even if there's a change that in the salinity that affects the phytoplankton and zooplankton, at the bottom of the food chain, then whatever eats them is not going to have anything to eat. And then of course that'll go all the way up to the top of the food chain, which is probably in this ecosystem, this pelican here. So you can see all of the fascinating mixtures of plants and soils and trees and creatures that make up a wetland ecosystem. And it's a very delicate balance.
We had a teacher that had commented about following some research. I noticed that you had there the mangroves, and something about the mangroves are slowly marching inland because of rising sea levels. And is that related to this?
Yes, because a plant can only live where it can tolerate the combination of moisture and temperature. And if mangroves are adapted to a specific salt content in water, and that changes, then the mangroves move. They'll move away from that area as we have perhaps more increasing salt content, and mangroves can't tolerate it. They'll move inland, and maybe if there's no place for them to move, they won't be there anymore. And of course, we know that mangroves are really an important part of the coastal wetland ecosystem.
So as the sea level itself rises, you've been researching this, and so I think you're probably the best person to make a guess, and I understand it is a guess because no one knows what will happen tomorrow. But as the sea level continues to rise, taking the assumption that it might, do you see beyond economic, are there going to be an array of additional environmental factors that are going to be impacted severely?
Well, yes, you said beyond economic.
Yeah, because I know economics wise, it's in like the first picture you showed with the restaurants and stuff are being, literally engulfed, but with the sea level rise. So the human infrastructure close by there, I expect will take quite a hit. But beyond that, have we changed the coastal region enough that the environmental impact is not going to be quite as severe, or is it actually going to be worse because of the changes we've made?
Well, one of the interesting maps that I've found is there are maps of growing seasons for plants throughout North America. And what's happening is as climate change has marched forward, we've seen certain species of plants, including wetlands plants, in places where we wouldn't normally see them because, for example, a lot of the places that are in the, I guess, mid-South are having, summers or just year-round temperatures that you might have experienced in Louisiana. And maybe for places in Louisiana are now more almost like tropical regions. And so it's really throwing a lot of things out of balance in terms of plant ecosystems, which again, of course, support zoological ecosystems. So it's I don't know. I mean, the IPCC report, there are still people saying, well, it's not too late. Maybe we can do something about it. I guess they're being very optimistic. But for the most part, from what I've read in some of the summaries, some of this is kind of irreversible. And the question that we have now is whether we're going to have mitigation or adaptation. And so mitigation is if we stop burning all these fossil fuels, go to electric cars. There's mitigation happening in coastal regions where these wetlands are being reconstructed by humans, which is extraordinarily difficult. If you've ever worked I've worked for the Bureau of Land Management years ago, and there were cases of where we had mining sites that were denuded by mining operations, and we go in and we try to replant, and a couple of years later, those plants would not survive. Interestingly enough, those same areas, if they got burned over, the plants would come back. So there's something about human intervention and destruction of ecosystems that takes a lot longer for nature to recover from than if nature does it him or herself. Nature, there's a volcanic eruption, destroys everything, maybe might take a while, but back comes the life even after, volcanic eruption just takes everything out. Yeah. But now if we do it as humans through our actions, it's very difficult to reverse. So or very difficult to, and even more difficult to fix, even with our own mitigation. And so there's a whole area called wetlands ecosystem mitigation that you can read about, and you can just see how difficult that is. I mean, all these, very intelligent scientists and ecologists will come together and reconstruct the wetland, and it might be fine for about 3 or 4 years, and then it'll just dry up. Whereas nature will create a wetland and it'll last as long as we don't mess it up, and so mitigation is when we try to fix something. Adaptation is when we just say, you know what, let's move inland. And that's what's happening in many places along the Gulf Coast. There are entire communities, especially in the lower Mississippi River Delta around Plaquemines Parish. There are entire communities that in the last 30 or 40 years are completely gone, underwater. And so it is, and so plants are going to adapt also if they are able to. But we humans have taken up so much of what would normally be an escape area or escape route for various species that they literally have no place to go. Whereas maybe at one time, if there was a retreat of mangroves or other plants or other parts of the ecosystem, they could retreat to upland land. That upland land is now parking lots, Walmart, your house, no place to go, and then they disappear. So we can certainly adapt, but it's in some cases going to be difficult for these species that are very much tuned to their coastal ecosystems balance to adapt if there's no place for them to go.
Wow. Yeah, that'll be interesting. Hopefully we can both mitigate and adapt to be able to help that environment. And those are some really awesome points, and a lot of the variables that you mentioned I would not have thought of with the you say the dissolved oxygen change. I did not even think about that. I mean, I should have, because with the lakes that we have, since we're totally inland here in the Midwest, the lakes we have and stuff, that's concern. And so with the dissolved oxygen, and so I should have, I guess that's just a lot bigger when you're talking coastal wise, but we just don't think with the coast being attached to the ocean, anything can happen to it because it's too big. But we certainly can, obviously, especially as you mentioned with the dead zones that we're getting there. And that's a frightening thing. And hopefully we can adapt in a positive way and start being able to help these areas a lot better.
Yeah, so here's some of the references that I use, the IPCC report and a couple of articles here, and the one by the Sunny Day Flooding article is a little easier to read. This is the journal article in Nature that you can try it. I know you might, I don't know, maybe when I was in high school, I don't know if I could understand it, but maybe you all now can figure it out. But it's just good sometimes to read something that's advanced, because it just gets you used to you might have to step up your game at some point. I remember when I was a freshman in college, all of the freshman courses were taken up, and I got tossed into this senior level environmental science, well, it was environmental studies class, and there were 7 required textbooks, 7, and I went in there the first couple of days, and it was like drinking through a fire hose. I'm just like, man, I don't know if I can handle this. And I went to the professor and I said, all the freshman classes were taken up. I had to take this. I'm an environmental science major. I didn't know that the 4,000 meant anything. I thought that might have been an arbitrary number. Now I realize that, I've gone right from the class A ball, and I'm in Wrigley Field. So,
No.
and all he said to me was, well, Padgett, you just have to, raise your level. Have a nice day. That was his advice. And so I had to raise my level, and I got an A out of the class. I never worked harder in my life, but what was interesting was that class was so difficult that even when I was working for the Bureau of Land Management, a lot of the foundational materials, like we had to learn the National Environmental Policy Act backwards and forwards. We had to learn the Clean Water Act. Part of the Clean Water Act is Section 404, Wetlands. I had to learn that backwards and forwards. And so when I was working years later, I still could go back to that foundational material from my freshman year of college. So read the article. Half of it might go by you, but you'd be amazed that your young minds right now, you don't have things called senior moments. Just ask your parents or grandparents about that. Your minds are like sponges right now. So you might actually read this stuff, not comprehend it, but maybe in the middle of your junior year of college, it'll be like, oh yeah. I mean, that's kind of what happened to me after that class.
Well, I love your suggestion of trying to navigate your way through some of these journal articles. And I think for some, it can even, it sort of explains why, like in the high school classroom, we make you write these lab reports, because it's sort of practice for getting to these journal articles and then seeing how scientists communicate with one another. And like you're saying, it sort of lays the foundation. Eventually you'll get to that level where you are referencing these journal articles, and just exposing yourself now, putting that challenge there now kind of helps you lay that framework for later. So we really appreciate all of your insights today on sea level rise, the impact on ecosystems, and just all the information and resources that you've given us. This has been good.
Yes.
Yeah, thanks for the invitation. I appreciate it. And if any of you all have any questions, here's where to find me. And that phone number, you can call it. That's not my personal number. It's not even my office number. That's a phone that I got as part of a grant.
Yeah.
Now don't laugh at this, but until last year when I got, this was my phone. This was my phone. This is not a pager. I was not going to cross over to the smartphone world. I was anti-smartphone. Can't track me on this. Can't follow me where I am. Can't track me on this. And then of course I got some COVID relief funds, and I said, okay, well, I guess I just have to buy a smartphone, and this is it. And so when you call that number, it goes to this phone. Mm-hmm. And so, yeah, seriously, if you have any questions about anything pertaining to this talk, or just give me a call. That's the number my students have.